Good afternoon, everybody, and assalamu alaikum. And for today, we will continue the last part of chapter 6, which is equally important, okay, because it's all about how you can draw the energy diagrams, okay. You will continue study this topic in chapter 7 and 8 soon, okay. So this one is just a beginning for you. So, and I hope after this you can discuss directly the exercise, okay. Let's go. Okay, energy diagrams is a schematic representations, okay, or of the energy change that take place as a reactant are converted to products, okay. An energy diagram is a plot energy of the y-axis versus the progressions of reactions, okay. Y is referred as energy, okay, often labeled as reactions coordinates on the x-axis. What's happened to my pen now? So okay, it's okay, it's working now. So you should have its y-axis. In x-axis you have this one is energy and reaction coordinate. Don't forget, okay, at least you can get 1 marks, right? If I'm preparing this kind of questions. Okay, again, so you have to label also the products. This is the products and this is the reactants. Last shape of the energy diagrams, okay. And you have to calculate label also the activation energy and also the delta H, okay. So it can be exothermic or endothermic. We will see after this the shape of the energy diagrams, whether it is exothermic or endothermic, okay. So the energy difference between reactants and products we call delta H, which is here. This is a delta H, okay. And as the chemical reactions proceed from reactant to products, it's passed through unstable energy maximums. We call transition states. In this one, because this is a single step reactions, it's only have one transition state. If you have multiple steps, you will have multiple loops, okay. And the energy difference between transition state and the starting material, okay, this is a starting material, and this is transition state. We call normally we label as a PS, okay, and we call activation energies, okay. And the larger activation energy, the greater amounts of energy that needed to break the bonds in this case, okay. And this one is the slower reaction rate because they need some amount of energy to transform starting material to the products, okay. The best one if you have the smaller activation energies by using catalyst or biocatalyst, okay. So transition state, the structure of transition state, okay, is somewhere between the structure of the starting material and product. It's in between, okay, the structure between transition state, starting material, and also the products. And any bond is partially formed. Okay, this is the partial structures. Okay, this one, partial broken. This one is partial forming. Okay, so any atom are gain or lose a charge contain a partial charge of transition state, which is represented as this symbol. Okay, and it should have in bracket like this, and also superscript double dagger. These symbols with this one. Okay, so okay, they have four situations in the shape of energy diagram. The first one is a slow, and this one is endothermic energy diagrams. Okay, they have, because it's slow, they have a large activation energy. This one, okay, which is slow reactions, and positive delta H, it's endothermic. Reaction. This one is starting material. This one is transition state. This one is product. Okay. y-axis, okay, x-axis, don't forget. Okay. Okay, the second situation is slow reactions. It's exothermic. The previous one is endothermic. This one is exothermic. If you see clearly, the shape of energy diagram is different, right? This is the positive values. Meanwhile, this one is negative values. Okay, you will see more, the clearer examples in chapter 7 and 8. Okay, so in this case, they will have a large activation energy in these situations. Okay, it means they are slow reactions. Okay, they have negative value of delta H. It's exothermic reaction. So this one is exothermic reactions. As usual, you will have starting material, transition state, product. Yeah. So what's happened? They have fast reactions, endothermic reactions. Okay, again, they should have low activation energy. In this case, it's low activation energies compared to this one, this one. Okay, so they have low activation energy, is fast reactions. Okay, the positive value of delta H is endothermic reactions. Okay, this one is endothermic reactions. Okay, the positive values. Okay, again, don't forget, this is the starting material from the left to the right. So starting material, transition state, product. Okay, again, this is y-axis, this is x-axis. Don't forget. Okay, so the fourth one, the last one, which is the last one, is the low activation energy, which is referred as a fast reactions, and the delta H value is the negative. It's exothermic. Okay, this one is exothermic reactions. Okay, the activation energy is from starting material to transition state. Okay, not product to transition state. It's a starting material to the transition state. So this is the starting material. Okay, transition state. This one is product. If they are negative value, it's exothermic. Again, y and x. Okay. So energy diagram and two-step reactions. Okay, this one we know, this one is a bond is broken. Okay, and after that this is bond forming. So this is the heterolysis of A and bond. Okay, a pair of electron will give it to A, and this one is become nucleophile, this one is become electrophile, and again we have a C as electrophile and nucleophile will attack the carbon diffusions, in this case is B, and form a new bonds. Okay, and energy diagram must be drawn in each step. Breaking the bond, have the intermediates, form the new bonds. Okay, so the two energy diagram must be combined to form an energy diagrams for the overall two-step reactions. Okay, so each step have own energy barriers with transition state at the energy maximum. Okay, for example, for this one, okay, bond breaking. Okay, so this is a stepwise reaction energy diagrams. What we have here, they have the heterolysis process between A and B bond. Okay, which is this one is the product starting material, and this one is transition state. Okay, you should show the transition state here. Okay, how it's and partially charged. Don't forget double brackets here and signage is double dagger. And again, you have to label x as y and x. Okay, in this case, activation energies Don't forget to labels and also delta H for this, the first process. Okay, and B is an intermediate. Okay, it means B and A minus is the intermediate in this case. Okay, so let's go for the step 2. Okay, so for the step 2, we have A, B here for the, okay, and C, B and C, and this is B and C here. Okay, again, don't forget to show the transistor state. Okay, transistor state 2. Okay, the formations between new bonds between B and C. Don't forget to put in bracket and signage double dagger. If they have the charge, in this case they have the charge, don't forget to put delta plus or delta minus. Okay, this is the generals. Normally in finals, we will give the value. It will determine the shape of the curve. Okay, if you remember, last night, Dr. Yam already sent an announcement in your e-learnings, and I explained you to have to submit, if I'm not mistaken, chapter 6. And they have already the values for that particular energy diagram. So based on that value, you can determine how much the EA and how much the delta H. Okay? And in this case, don't forget to label activation energy, EA values, and delta H. Okay? So in this case, you will have two curves here. Okay, this is the first transition state. Okay, this is the second transition state. Okay, and this is the intermediate. Okay, and this is the starting material, and this one is the product. Okay, you should have, in this case, if there are two-step reactions, you should have two activation energy, which is this one, and also two delta H. Okay, and there is another additions if there are two-step or more step reactions, which is delta H overall. Okay. Okay. Is delta H overall is the energy difference. Okay, is the delta H overall for the two-step process. Okay, and this one you can determine the reaction is exothermic or endothermic based on the value is positive or negative. Okay, so kinetic and energy diagrams. Okay, kinetic is a study of reaction rate. Okay, kinetic, it's regarding the movements. Okay, if we talk about kinetic, it's regarding the movements. In organic chemistry, we relate it with the rate of reaction. If the thermodynamics, it's regarding the temperatures. Okay, you give heat or okay. So activation energy is the barrier that must be exceeded for the reactant to convert to the products. Okay, so in this case, if the activation energy is higher, like rate here, it's the slower reactions. Okay, and if there are lower activation energies, there are faster reactions. If the activation energy reach until these levels, the reaction is favorable back to starting material. Not going forward, it's going backwards. Okay, that's why, for example, for the examples, they need the energy. You have to heat the reactions, okay, around 80 degrees. Okay, if you heat more than 88 degrees, so they will give us, it will reach the some amounts of activation energy, and the reactions move forwards. Okay, if the reactions, for example, you want to try the reactions and it done at room temperatures, it's probably then not going forwards. It will maintain at the starting material. Okay. So the best one is if you can manage to lower down the activation energies, and the reaction will be going to forwards. Okay, and probably the reaction time will be lesser. Okay. So a factor affecting reaction rate, the higher concentrations, the faster the rate, okay? The higher the temperature, the faster the rate, okay? Delta H, delta G, and K equilibriums do not determine the rate of reaction. Yes. Okay. You will see more this factor in chapter 7 and chapter 8. What's happened, for example, what happened if we increase the temperatures? What happened if we increase 2 times the concentration of reagent A, for example? What happens for the reaction rate? It will increase 2 times, for example. You will see more about this example in chapter 7 and chapter 8. Okay, so these quantities indicate the direction of equilibriums and relatively energy of reactant and products. Okay, so rate law is the rate equation that shows relationship between reaction rate and the concentrations. Okay, so in these experiments determined by measuring decrease of concentration reactants or the appearance of product over time. Okay. So fast reactions have a rate of large rate of constant. Okay, you know that. I think you have to remember and understand about this one. Okay, rate equal to K reactants. Okay, not the products, reactants. So slow reaction have small rate constants. Okay. Rate equations, the rate constant K and energy activations are inversely related. A high activation energy corresponding to a small K values. So the rate equation contain concentration terms for all reactant in one-step mechanisms. Okay. The rate equation contain concentration terms for only the reactant involved the rate determining step in a multiple step reactions. Okay. The order of rate equation equal to sum of exponents of the concentration terms in the rate of equation. For example, this one is the second order rate equations, okay, because they have intermediates here. So the rate is equal concentration AB and C. Okay, this is the starting material and starting material. Okay, it's a sum of exponential is 2. Okay, it means both reactants are involved in the only steps and both reactants determine the rate. It means if you increase two times of concentration AB, it will getting faster technically. Okay, so I think in chapter 7 we will discuss more about this one. It's better to have the real example for them. Okay, so rate equation for two-step reactions. Okay, two-step reaction have slow rate determined step. Okay, it's two-step reactions, slow rate determined step, and a fast step. So in multiple step mechanism, the reaction can occur no faster than the rate determined step. Okay, so everything is depend on the rate determined step. So only the concentration of reactant in rate determined step appear in the rate equations. Okay, so for example, this is the A and B. Okay, it's step 1 is the rate determined step. Okay, so there is only one concentration term is depend on the concentration of A and B as a starting material. Okay, so this one in this case, this is the first order of rate equations. Okay, it's depend 100% only to AB concentrations. Okay. So for application of catalyst, I think this is the last few slides. Okay. Some reactions do not proceed at reasonable rate unless the catalyst is added. For example, this process we call apa? This process is what?
Esterification.
Yes, good. Okay, this is the esterifications process. Okay, to form ethyl acetate. So to do that, we need acetic acid and ethanols. Okay, if we don't put in acidic media, okay, because of uric acid as the catalyst, So if we not put sulfuric acid as a catalyst, probably the reaction is quite slow and it will take a long time. Okay, so for example, this one is hydrogenation process. Okay, hydrogenation process. Okay, we need cyclohexanes and also hydrogens, but they need palladium catalyst to do that. Okay, otherwise the reaction will not happen. Okay, this is my favorite reactions during my PhD. Okay. Okay, the role of catalyst, the catalyst substance that speed up the rate of reactions, okay, by lowering the activations energy. Okay, you can see the reactions here. This one, the red one is the without the catalyst, and if we put the catalyst, the activation energy is going down, and the reaction will be faster. Okay. Enzyme is the biochemical catalyst. In our body, we have a lot of enzymes. For example, in our mouth, we have apa? Siapa tahu? Enzim apa kat mulut?
Amylase.
Amylase. Good, Chanji. So, okay, amylase. What else? In our intestine, we have a lot of enzymes. Okay. And there are biochemical catalysts that compose of acid amino held together to very specific in three-dimensional shapes. Okay, so an enzyme contains the radioactive sites, okay, that bind with the organic reactants, and that we call substrates. Okay, and the resulting units, combinations between enzyme and also substrate, we call enzyme substrate complex. Okay. Once bound, the organic substrate undergoes a very specific rotations at the enhanced rates. Okay, anybody who love working on the pharmaceutical part and also medicals like myself, okay, we are playing around a lot with enzymes, okay, because we manipulate the enzymes, how the drugs will interact with enzymes, okay. So the products this release, and this is kind of lactase, okay. They break the lactose to the small units, to galactose and glucose, okay. And this is the active sites we call active pockets, okay, for examples. But as a chemist, we are crazy sometimes, okay. We want to reduce the absorptions of sugar in our body. We build similar like lactose to block the active site, for example. Okay, so I think that's all for the lecture for chapter 6. I think everything is covered. So I'm happy to be with you, everybody. So before we finish, we proceed with the discussion questions. Okay, and I will close this one first. Start. So we find yes. Okay. Okay, I already give you a few questions, not from the books. Okay, I think this question is from the previous version of books, not recently, but maybe they have a similar question, set of questions. So, okay, around the indicated bond, okay, in order increasing bond dissociation energies, okay. So, okay, let me see. Okay, in this I just put some notes here. No, it's my pen here. Okay, so increasing, okay, increase number of electron, okay, between atom equal to increasing bond strength equal to increasing bond dissociation energy, bond dissociate energy will decrease bond length. Okay, so okay, this is the first one. The second one, okay, increasing size atom, okay, with increasing bond length. Also with decreasing bond strength. Okay, in this case we have to rank. Okay, so this one is iodine is the largest halogen, and it will be weakest bond. Meanwhile, for chlorine is a small halogen. So this one is a strongest bond, and bromine is intermediate, in between. Okay, in the okay, so bond strength. So from these observations, you can arrange by yourself. Okay? Takkan nak buat semua kan? Ada bagi dah. Okay? So, next question. Okay. Okay. Homolysis is the of the indicated CH bond, which is here. Okay, this one. Tak nampak color kan? Okay, in propene form a resonance stabilized radical A. What they ask you to do it. First, draw the two possible resonance structure for these radicals. Okay, so first we have to remove first the proton here. So you will get, okay, so and what you can do is you have to go here. So this one going here, this one going here. So okay, the second resonance. Okay, use half radical resonance. Oh, ada jawapan dah. B. Okay, A and B here, A and B here. Draw the resonance hybrid. So from these two, I and second Romans here, draw the resonance hybrid. This one is chapter 6, chapter 1. Okay, so hybrid, draw all the sigma bond. Okay, so you can see this is the movement of an electrons. Okay, so you will be delta. Okay, again. Okay, this is the hybrid structures. Okay, Kata rambut lah. Rambut dah tadi kata kepala lah. Okay, next. Okay, we go to the second. Okay, give each values. Okay. Given each value, determine whether the starting material or product is favored at equilibriums. So we know that K equilibrium is 0.5. Okay. We know that. Yeah. This one is K equilibriums less than 1. Less than 1. It means its starting material favored. Okay. Okay, B, delta G is minus 100 kilojoule per mole. Okay. Macam mana nak tulis? Okay. Delta G not less than 0. Okay. So they are favored to product. Okay. So next, delta H. We already studied yesterday, right? Delta H is around 8.0 kilojoule per mole. Okay. Tengok vektor dia. Okay. Delta H not is positive. So, okay, starting material favored. Okay. So, okay, K equilibrium in this case is is greater than 0 than 1. Okay. So favored to product. Okay. So delta G. Okay. Delta G not okay greater than 0. Okay, so they are favored starting material. Okay. Delta H not is positive. So they are favored product. Betul tak? Okay, tak apa, no comment. So, okay, in this case, we already touched equilibrium, delta G, delta H. So, why not entropy? Okay, entropy. Okay. Delta S not is greater than 0. Okay. Starting material is favored. Okay. Delta S naught is less than 0. Product is favored. Okay. Ada siapa nak komen?
Doktor. May I know why delta H is positive for why favor the product for the F? Is it?
Saya saja tulis. Nak tengok betul tak betul. Alert tak alert. Okay, this one is for F.
Material.
Starting material. Saja je buat. Dan nak tengok you buat tak buat. Starting material. Okay, how about this? Ini betul tak?
Balik.
Balik. Betul. This one is product. This one is material. Okay. So again, by using these tables, you can see the variables. Okay, the value k equivalent more than 1, less than 1, what's happened, delta G, delta H, and entropy. Okay, this is kind of summarized. You can use these tables to answer this kind of question. I just saja ya buat nak tengok you all letak. Okay. Okay. So, okay, draw the energy diagrams. It's okay, draw the energy diagram for the reaction with products are higher in energy. They have a few clue here. They have a few clue here. So what they said higher in energy than the starting material. This is the first clue. Activation energy is large. It means the loop is quite higher. Okay, so clearly label all. They already instruct you to put all the labels on the following diagrams: the excess, starting materials, the products, the transit states, delta H, and activation energy. So there's all informations you have to put inside the energy diagram. So this is the answers. Okay, you should have a y-axis. Okay, this is y-axis, and this is x-axis. What they ask is a large activation energy. So if your diagram is like this, so no, this is a small activation energy. The large, it should be like this. Okay, at least we can differentiate between large or small. Okay. Again, starting material, you have two labels. If they mention starting material, yes, just starting material. If there are A, B, for example, A, B here, yeah, they are A, B, and transition state maybe A, B, C, maybe. Okay, but you have to put transition state in a good order. Okay, so in these times, what they ask, if they ask about exothermic and endothermic, the shape will be different. The end shape for the products will be different. Okay, it's depend on the delta H values, whether they need a positive, negative, or positive. Okay. Okay, I hope it's clear. Okay, this is the basic about the energy diagrams. Okay, I just see the reactions from Chanji. If they are okay, angguk kepala, I proceed. If they geleng, I sambung lagi. Okay, next. Okay, draw the structure for the transit state in each directions. Okay, you can easily refer 6.17. Okay, so we will do. Okay. Okay, in transition states, you have to draw in dashed line to indicate the partially broken and partially formed the new bonds. And you have to put a partial charge if they have it, okay? And also you have to put the in brackets and also the double decker, which is represented the transition states. So, oh, it's already stated here. So this is the transition state for the A, and this is the transition state for the B. Okay, don't forget brackets, double daggers, the partially charged here. So this is dash, right? Dash lines to represent how bond breaking or bond formings. Don't forget if they have charge. For example, this is positive charge, delta positive here. Okay, delta positive here. Also, okay. The delta is a partial. It's mean partial. Okay. So I think it's quite right. This one, how to draw the transition states. This is the explanations. I think we already covered during the lectures. Okay, for example, this is the partially broken. broken bond. This is partially forming the new bonds. Okay, don't forget the charge. We have both charge here, the brackets, okay, and also the double decker. Okay. Okay, compound A can be converted to C or B or C. The energy diagram for both process are drawn in the graph below. So what you have to do is label each reaction as exothermic or endothermic. Okay, first one, you have to choose between red and blue which one is the reaction fastest. It's related with the activation energies. Okay, which reaction is generate the products lower in energies. We will see after this. Okay, number 4, which point of the graph corresponding the transition states. Okay, transition state is the formations between starting material and products. There be in between. Okay, in this case, D and E is a transition state. Okay, label the energy activation of each reactions. EA, you have to label the EA. Lastly, label the delta H for each reactions. Okay, you have to label delta H, not whether they have a positive or negative values, whether they are exothermic or endothermic. Okay, the answer is this. Okay, first A and C is exothermic because you have to see the delta H value overall. So for A and B, you have to see the delta H values, whether they are positive or negative. Okay, so we will see for the B, what's the question? Faster reactions, you have to see the activation energy values. Okay, to make it easy, you have to make a dash line. Using a dash line, it's easy for you because you can see the difference between products and also starting materials. Okay, for the D, what is they ask? Which point the graph corresponding to transition state is the D and E's transition state. Okay, and E, what is E? Number 5, label the energy activation of the each reactions. Okay, this is the activation energies. Okay, between activation energy is between starting material and transition state, not product to transition state. Okay, so F, this is delta H, so you have to label the delta H. Okay, don't forget to label. This one is a y-axis, this one is x. Make sure y is energy, is E. Reaction coordination, you have to write in full reaction coordinations. Okay, consider the following energy diagrams. Okay, this is 2-step of reactions. How many steps are involved in these reactions? We already covered this one. It's 2-step reactions. Label delta H, EE for each steps. It's mean 2-step reaction. They have 2 delta H, 2 activation energy, and additional ones overall delta H. And you have to label each transition state. Okay. And which point the graph corresponding to reactive intermediates is quite important. Okay, which step is rate determinant step? If there are 2 or more reactions, they are depend on rate determinant step only in terms of driving direction to move forwards. Okay? So is the overall reaction exothermic or endothermic? Is depend on delta H overall. Okay, so this is the answer. Senang, copy paste kan. So, okay, there are 2-step reactions because they have 2 loops. Okay, because they have 2 energy barriers. In scientific, kalau kita cakap kampung-kampung ni, there are 2 loops lah. So, for the B, what they ask you, label delta H and everything. So, you should have 5 labels here. 2 activation energy, 2 delta H1, delta H2, and another one is delta H overall. Okay. For the C, what they ask, label each transition states because this one is 2 reactions, 2-step reactions. They have 2 transition state, which is transition state 1 and transition state 2. And of course, if they have transition states, they should have reactive intermediates. Okay. Okay, and the first step is this one, this step. Okay, is the rate determinant step because it transition state is higher energy. So it means they have to reach a certain activation energy to make sure the reaction move forward. It's depend 100% for this step. Okay. So F, the overall reaction is endothermic, okay, because the energy product is higher than energy of reactants. Okay, so it's depend on delta H overall. Okay, to determine the overall reaction is the endothermic or exothermic. Okay. Again, don't forget to label all the energies, excess, okay. So they have in this chapter also we already covered about the types of reactions. In general, you have substitutions, eliminations, and additions. Okay, this is the basic. Okay, if the reactions are named based on the inventor, for example, Grignard, they are still using these terms. Okay, substitution, elimination, or additions. Okay, they are still using them. Okay. So, okay. So this is kind of additional notes about the bond dissociation energies, okay, energy and stability, activation energy, rates of reactions, okay, rate constants. This is kind of summarized, okay, that you will find in your lecture notes and also the books, okay. So again, in the beginning, we already covered about the homolytic and heterolytic cleavage. Okay, for this one, for example, radical reactions, it's involved giving one electrons. Okay, an electron only. Okay, not pair of electrons. Between and also the formations of carbocation and carboanions is regarding with the another types of cleavage of the bonds, okay, will form the carbocation and carboanion, which is referred as electrophilic and nucleophilic, with what we already studied in chapter 2. Okay, in chapter 2 and chapter 3, we covered about electrophilic and nucleophilic. You will see again these terms in chapter 9 to 11. Jangan buat nanti lo tayuh nanti baru nanti. Okay. Okay, again, for this kind of summary for today, I guess, rate determinant steps, okay, if they have a higher activation energy, it means the reaction is slow. And you have to also determine whether the reaction is exothermic or endothermic based on the values of positive or negative for the delta H. Okay. This is kind of example. I just make a summarize for you. It's easy to see the difference. Lower activation energy, the reaction is fast. Higher activation energies, so the reaction is slow. Okay. How you want to reduce the activation energy by using catalyst or biocatalyst, which is referred as enzyme. Okay. Okay, boom. So, okay, this is kind of summarized regarding the energy diagrams. Okay. Kinetics is depend on the concentrations and also the temperatures. You will see more this one in chapter 7 and 8. Okay. I think, okay. Okay, this guy. I will stop sharing. Okay, thank you very much. I think it's already finished for chapter 1 and chapter 6. It's tiring, right? So hopefully I can see. Oh, dah ngantuk dah. Apa tu? Marcus ngantuk dah. So I hope to see, maybe on next Monday we don't have any class. I just give you a break for a while. Maybe you can try to do your assignments that are given by Dr. Yam. And maybe on next Wednesday, you will start chapter 7. Okay. And I will give you the right to Dr. Yo to handle the class. So when you coming back for the next quartile, so if you have any problems to discuss face-to-face regarding this one, you are welcome to visit my office. Okay, because anybody who are from biologists, my office with biologists are just in front of the schools. Okay, just datang ya. Okay, no problems. Okay, I think that's all for today. I will post this lecture note, the last one lecture notes, and looking forward to get the response from you. Okay, we will do some surveys. I think maybe next couple of weeks regarding the teachings. So if you have any comments for the teaching specific for my part, you are free to do so. Okay, okay. Jangan risau, nama tak ada dalam teaching tu dalam komen tu. Okay. That's all for today. Stay safe, stay healthy. Sampai jumpa lagi.
Come on, shorty, let's go. Girl, I see you over there in the corner of the dance floor, and I know you're acting shy, looking at the corner of your eyes. So I pick my heart up off the floor, move my feet closer to yours, catch my breath, and I say, I'm the one you're looking for. So come on, dance a little dance, take my hand, darling, take a chance. You be my queen, I'll be your king, show you everything that you've been missing, shorty. So come on, dance a little dance, got me in a trance in just one glance. So don't wait no more, I'm more, I'm the one you're looking for, shorty. Oh, girl, I see you over there hesitating, deliberating, you keep me waiting on a sign, looking at the corner of your eyes. So I pick my feet up off the floor, move my hips closer to yours, catch my breath, and I say, I'm the one you're looking for. So come on, dance a little dance, take my hand, darling, take a chance. You be my queen, I'll be your king, show you everything that you've been missing, shorty. So come on, dance a little dance, got me in a trance in just one glance. So don't wait no more, I'm more, I'm the one you're looking for, shorty. I'll be the one you're looking for, shorty. So come on the dance floor and baby show me all your moves, all your grooves, shorty. I got something to prove to you. So come on, take a little chance, got me in a trance in just one glance. So don't wait no more, I'm more, I'm the one you're looking for, shorty. So come on, dance a little dance, dance a little dance. Come on, dance a little dance. So come on, dance a little dance, take my hand, darling, take a chance. You be my queen, I'll be your king, show you everything that you've been missing, shorty. So come on, dance a little dance, got me in a trance in just one glance. So don't wait no more, I'm more, I'm the one you're looking for, shorty.